to the March update for this new video series on Project Data Science news. Today I'll be looking at some of the more interesting March PowerBI updates. I'll also be giving an overview of Neo4j's Graph Tour London that I visited this month. And also, if you remember the last video we recorded, we looked at some classification of some project RAG ratings using supervised machine learning methods. We'll be taking another look at this, but this time using some deep learning.
So let's jump straight in with the March PowerBI update. There are a lot of updates to the reporting side of Power BI this month. So now you can do single select slicers, there's some updates to heat maps, and there are a lot of tooltip updates as well. So now you can write JSON code to make sure all your tooltips are completely consistent. But there's some more interesting updates, in my opinion, on this new modeling view. So you can now bulk edit your columns, and you can also drag and drop into your display folders here, which you couldn't do before. And what's even more interesting is now there are multiple diagram layouts. So there's a simple diagram layout where we've just got a mapping here between calendar and sales. But actually, if we want a more complicated version of this, so rather than looking at just a subset and the submodel, we can look at the whole model if we want to, and we can have as many of these different views as we want to keep things as simple as possible. So I'm a really big fan of that. And there are some custom visuals as well. So the more interesting custom visual for me is this new regression visual called a Cray deck regression chart. So here in this plot, I've actually, just waiting for it to load, I've actually plotted unit price against units, and you can see that the visual has actually plotted its own linear regression line in there as well. But the interesting thing about this visualization is that I can segment the data. So if I drop in sale size into the subgroup, for example, there are 3 different sale sizes, small, medium, and large, and it's actually segmented the data and then plotted its own linear regression for each of those segments. I think this is really cool. So I wanted to talk briefly about a really interesting conference I went to hosted by Neo4j called Graph Tour. So this was on the 26th of March, and the CEO of Neo4j, ML, started off the conference by talking about the popularity of graphs. And I knew that graph databases in the last 5 years had really been growing in popularity, but I had no idea to this extent, especially when you compare this with relational databases in red. So a really interesting insight into the future, I think. So there was a big focus at Graph Tour on how graphs will be adopted and improve machine learning. So I pinched this picture from ML Slides, and it's a mini graph of who he was the father of, that he works at Neo4j, who he's married to, that he plays the piano, and he watches these TV programs. And the idea is that this conventional method of machine learning, where you load this data in a row-like format, isn't as predictive as if you take who else works at Neo4j, and who else plays the piano, and who else watches Game of Thrones, and who else was born in Sweden. Well, granted, that's a lot of people. So rather than loading in your data in this kind of row-like way, which kind of seems kind of archaic now, and you get some machine learning pipeline and then you have some decisions, you can actually look at the connected nature of all of this data. You can push that into your machine learning pipeline, and then out of that you get better decisions. And I think this is the future. So finally, let's look at this RAG classification problem that we were working on last time. And just as a quick reminder of some of the supervised machine learning models that we used last time and how well they performed. So we started off with a naive Bayes classifier, which had an accuracy of 54.5%. We then went on to a logistic regression model, which had an accuracy of 69.6%. And then finally, we used a support vector machine model, which had an accuracy of 75.5%. It's worth bearing in mind that we only had 1,000 rows of data here from the GMPP data, the government's major project portfolio data. And that generally speaking, I think some deep neural networks require quite a lot more data than that, but we'll see how we get on. So I started off using the Keras Python package, which is an API for TensorFlow. And it's a relatively good starting point, actually, if you want to get kind of moving with deep learning. So again, I imported the data using pandas, and I did various bits of pre-processing. But I actually used 3 different types of neural network. So I used feed-forward, convolutional, and recurrent. So you can see we started off using the feed-forward approach. And the accuracy of this wasn't actually that great. It came out at 39, or just over 39%. Again, this could have been, data related. The next method, the convolutional approach, wasn't massively better. Again, around the 39, sort of 40% mark. And then finally, the last neural network, the recurrent neural network, was the best performing one, but this actually came out at 41%. So, okay, the neural networks weren't quite as good as your traditional approaches. This is almost certainly due to the fact that we've only got 1,000 data points. So as I made a call last time for more data, if anybody knows where we can have labeled project data, by labeled I mean RAG labeled project data that we can web scrape or collect and using some API, then please contact us. And the sooner we start that, the sooner we can start to bump up the accuracy of these models.